Hi everyone. We're going to continue today talking about equations, in particular about the first degree equations in one variable. I'll remind you that an equation has one equal sign and one or more variables. As the title states, we're going to talk about first degree equations in one variable, which I would generically denote by x. And first degree means your variable's highest degree is 1, meaning you're not going to see any x to the power of 2, any x to the power of 3, nor any higher power, just x to the power of 1, which is x. You will mainly have to separate all the terms that have x on one side and all the terms that don't have x on the other side. Once you get into this format, in order to find x, you will have to divide both sides by the coefficient of x, which in our case is a, assuming a is not 0. If it's 0, that's a totally different case. Hence, your solution is going to be x equals b over a. So our solution. Once you find your solution, you have to, well, not that you have to, but I would advise you to check it. Sometimes the solution is too ugly and it will require a lot of calculations to check it. But if you have a calculator, feel free to do it, but don't waste too much time on checking it. So let's see how I taught you previously how to bring the first degree equation into this form, ax equals b. So separate all of the terms with x on one side, all of the other terms on the other side. I made a parallel between positive terms, which I said, oh, you can think of them as being happy people, and negative terms, which I said you could think of as being sad people, upset. And consider that you have two rooms, the left room and the right room, connected with a hallway. Okay, this is our equal sign, remember. And in order to separate all of the terms that have x's on one side, you would have to move some terms from one side to another and so on. And in order to do that, you have to keep in mind that if a term is positive, or if a person is happy in being in this room, once you move them into the other room, they will turn negative, or they will be upset. If a person that's positive in this room gets to be moved on the other room, it will turn negative as well. And the same thing if you have a sad person or a negative term, you have to move it on the other side, it will change its sign. Okay, so remember that. As for an example, let's start with one of them. So a very basic one, 3x minus 4 equals 2x plus 5. Just take a look at the question first, analyze it a little bit, a few seconds. How many terms do we have? You're right, 4. So 1, 2, 3, 4. How many terms have x? 2, right? 1, 2. So if this is the left side and this is the right side, respectively the rooms, I want to bring all of the terms that have x onto the left. So 3x here is in the left room, I can leave it that way. But 2x, I have to bring it here. So what happens? It will change its sign. What's the sign of 2x? It's a positive sign here. You don't see it, but it's positive. So once you move it onto the other side, it will turn negative 2x. No other terms that have x, so we move on to the right side. What's into the right side? 5. 5 stays the same way, fine. Do we have any other terms that don't have x? Yes, we do have -4, which is in the left side, in the left room. So once you move it into the right room, it will become +4. It will turn +4. 3x minus 2x, they're like terms, so we can compute them. 3 minus 2 is 1x. Again, we don't write the 1 because you can see there's 1x. Equals 5 plus 4 equals 9. This is the solution, but is this correct? Let's check. So checking is not mandatory unless specified. So if the question asks you verify your answer, you have to, because otherwise you're going to miss marks. If they don't ask you, you don't have to, but it's good to check it such that you'll see if you made a mistake or not. Each time when you check a solution, you have to replace the value that you found, your potential solution, into the original equation, into the initial equation. So what do you have to do? Very simple. Everywhere you see x in this original equation, you're going to replace it by the value that you're checking. So you have 3 times x, okay, minus 4 equals 2 times x plus 5. That's my original equation. All you have to do, instead of x here and here, you have to write your solution that you're looking for, 9, 9, correct? So 3 times 9 minus 4 equals 2 times 9 plus 5. And from here, you just use order of operations. 3 times 9, 27, minus 4 equals 2 times 9, 18, plus 5. 27 minus 4, 23. 18 plus 5, 23. So 23 equals 23. Hooray, our solution is right. We're good. Had we gotten here to a different numbers, different situation, 23 equals 9 or whatever, something that was not true, there were two situations. Either your solution is not the proper one, or you've made an error here someplace. So you have to check both. So let's continue with a more complex example that will involve also some brackets. I'll remind you that we're going to use the property of multiplication being distributive over addition and subtraction. What does that equal to? Feel free to pause the video each time to answer, okay? So A would multiply every single term inside the brackets. We have two terms, so we'll multiply it by the two terms not in the same time. So A times B, AB, plus A times C, fine, AC. If it's a minus here, it's a minus here. I'll remind you that if you have a negative number before the bracket, it will change the signs inside. So it's going to be -2 times 5a, -10a. -2 times positive b, it's going to be -2b. So just pay attention, as you can check it really fast by looking at the two signs or all of the signs inside of the bracket, and instead of plus plus you're going to have minus minus if you are multiplying it by a negative factor. Okay, so my second example would be 2 times x plus 1 minus 3 equals 6 minus 3 times bracket 2x minus 3. Pause the video, solve it. Assuming you paused it and you're checking your solution, let's see how we should do it. You're multiplying 2 times x, 2 times positive 1, so plus 2 minus 3 equals 6 minus, sorry, not minus, anyway, -3 times 2x, -6x. -3 times -3, plus 9. Now let's move everything from the left side, or separate the terms that have x on the left side and the other ones on the right side. How many terms do we have? You're right. 1, 2, 3, 4, 5, 6. Out of these 6 terms, how many of them have x? 2. 2x is already in the left room, so I'll keep it here, while 6x is into the right room, so I'll have to move it here. What happens when you move it from one side to another? Correct, it changes its sign, so plus 6x equals. No other terms that have exist, so let's see, on to the right side, what terms do we have? 6, positive 9, and we have 2 more that are in the left, on the left side, so we have to move them here. What happens when you move them? They change their sign, so negative 2 plus 3. Like terms, 2x plus 6x equals 8x equals 6 plus 9, 15, minus 2, 13, plus 3, 16. And now we're in that situation, that format, ax equals b, where I told you we should divide both sides by the coefficient of x, which is a. Let's see, what is the value of a in my example? 8, right. What's the value of b in my example? 16, you got it. So divide both sides by the coefficient of x, which is 8. Simplify. X equals 16 divided by 8 is 2. So that is our potential solution. Let's check it. Where do we check it? In the original equation. So I'll copy it, though you don't have to do it. For me it's easier because I can erase it anytime. I'll copy, I just copied the initial equation. And now instead of x here, I'm going to write my solution 2. Instead of x here, I'm going to write my solution, which is 2. And now order of operations and solve it. 2 times 2 plus 1, 3, minus 3 equals 6 minus 3 times 2 times 2, 4, minus 3, 1. 2 times 3, 6, minus 3 equals 6 minus 3 times 1, 3, which is obvious. That is correct. So our solution is correct. Now it's going to be your turn, and I'm going to give you some questions. I'm going to send you a handout that you have to solve. Have fun. See you next time.